Okay, today we're going to go ahead and create professional arguments using a format that we call claim evidence reasoning. So, whenever you are engaging in science, you have to be able to you have to be able to create arguments in order to support what you're saying. Okay, so when we're creating these arguments, I want you to use this claim evidence reasoning format so we are consistently creating an argument that is valid and that gets across easily. Okay, so let's go ahead and go over what claim evidence reasoning is. So let's just break it down first. What is it? And then we'll go over some examples and then we'll practice ourselves. Okay, so claim. The claim is just a statement that gives an answer to a question. So if the question is, for example, why is the sky blue? Your claim would answer that. Okay, your evidence is the data that supports what you just said. So if you just said something, you got to back it up with facts, examples, graphs, so forth. Okay. Reasoning. This is usually the hardest part. It's basically how does your evidence prove your claim? In other words, how am I going to explain what I said something, I provided evidence, and I have to explain how those two things are connected. Okay. It's sometimes a sort of repetition of the claim, but that's not always necessarily the case. Okay, this is just another way to look at it. Again, claim is the answer. Evidence, it must be appropriate, meaning that it must match what you're talking about. It can't just be some random piece of evidence. Sufficient in this class, you want to have at least two pieces of evidence in order to be sufficient. Again, sufficient means enough. We have enough evidence there. Okay, and reasoning. Eventually, we'll be bringing in scientific principles to support what we're saying. But for now, we're going to do very easy CERs or claim evidence reasoning. I just say CERs to shorten it. We'll be doing simple ones that you won't necessarily need scientific principles for it. Okay. All right. So let's look at a simple question. Do cockroaches prefer light or dark environments? I want to go ahead and create a CER for this. Okay. So I'm going to show you guys a good example. I'm going to show you a bad example, and we'll try to identify different components of it. Right. Here's example one. I'll read it all over. We'll read it all at once, and then I'll go back and kind of break it down. Cockroaches prefer dark environments. When we let 10 cockroaches choose between the light and the dark side of a box, 9 of them chose the dark side. Since more of the roaches chose the dark, we can tell that that is what they prefer. All right, so let's go ahead and look at this. Let's try to break it down and look at what is the claim, what is the evidence, what is the reasoning, right? Well, what answers the question? Obviously, the first sentence, they prefer dark environment. So that is my claim. My evidence, well, they provide two pieces. They provided one piece of evidence actually, right? So this would be my evidence because they said that 10 roaches. They put 10 roaches. 9 of them went to one side. The other one went to the light side. Okay. Since more of the roaches chose the dark side, we can infer that is what they prefer. That would be my reasoning. Okay. A lot of times reasoning starts with like therefore or like kind of just summarizing these two components, but I'll show you guys more examples in a bit. Okay, let's go ahead and erase this. All right, let's go on to the next slide. It's a different clip. So it says, do cockroaches prefer light or dark environments? Same question, different response. Cockroaches prefer dark environments. Okay, so that's an appropriate claim. That's still answering the question, right? They want to hide from us. That's what does wanting to hide from us have to do with preferring a dark environment? So is this evidence? Yes, but is it appropriate evidence? It's not appropriate because it doesn't really support what we just said. Okay, so because cockroaches have those long antennas, maybe they can just feel their way around and don't need light to see. That doesn't have that reasoning doesn't connect these two. So we said two things, but that reasoning doesn't connect. It's hard to connect it when your evidence doesn't make sense. So this would be an incorrect reasoning. Okay, so I just want to show you guys an example of something that was done well and something that was done, well, you can say not so well. Okay. All right, let's move on here. So what we'll be doing in Zoom, if you missed that Zoom, you will have this, we'll watch this video clip in which a girl is describing a scenario, and using that video clip, you will be creating a claim evidence reasoning within the class. But that's part of the Zoom session. We won't do that here. Okay. Okay. let's look at a question, and we're gonna create our own claim evidence reasoning based off of this. Okay, so back in the 1800s, people were unsure where maggots came from, or maggots which eventually become flies. They thought, well, or what they would see is that they would leave a piece of meat out, right? They would leave a piece of meat out. A few days later, they would they would magically see maggots popping out on that meat. Well, a lot of them thought that just came out of thin air, that it was spontaneous, what they call spontaneous generation. It just magically generated out of thin air. However, there was simple tests that were conducted that went against this idea. Okay, this is the test we have here. So what they did is they, or even before that, let's go over the two leading claims that were there, right? So there was two leading claims there. One claim was that flies, or let's say larvae, they become flies, right? Larvae are produced from other flies touching the meat. Okay? This actually wasn't the main claim. The main claim was flies are generated are generated when meat touches touches the air. So basically, just because they're simply touching, they will automatically generate. Okay, flies are generated when meat, or let's be more specific, the larvae. Okay, those larvae are generated when the meat touches the air. So it has nothing to do with other flies coming in and laying eggs or anything like that. They didn't know anything about that at that point. Okay, let's go back to our experiment and kind of explain it. So if we look at our experiment here, we had three containers, right? This first container, open, it allowed flies to touch the meat, and we had maggots. All right, cool. That kind of supports the counter idea, right? That when the air touches, flies will happen because there's air touching. But it also supports that flies need to touch it because they're gonna. That's what produces the larvae, right? Then we have our second experiment. When the flies couldn't touch it, only the air was in there, right? There was no maggots. All right. So if we stop there, yes, that these two can be used to support our theory, but this doesn't tell us this doesn't give us. Oh, actually, sorry. In this sealed flask, there was no air and there was no flies. Okay, so that doesn't tell us that the flies didn't do it. It didn't tell us that the air didn't do it because there's no air in there. Okay, the last experiment, air can get through, but the flies can get through. So the air can touch the meat, but the flies cannot touch the meat. And what did we see? Well, we saw no maggots. Okay, so let's go ahead and answer the question above. Are larvae produced from meat and air contact, which is what a lot of people thought, or other flies contacting the meat? Well, from this experiment, we should see that when the flies can't touch it, like these two examples, there's no larvae. When the air touches it, if it's only air, there's no larvae. So it must be the flies. The flies have to touch it in order for it to produce larvae. Okay, so let's go ahead and create a claim evidence reasoning for that. So what's my claim? Well, my question was asking me, what is it? How are flies produced essentially, right? So larvae are produced from other flies touching the meat. Okay, and make it a little bit smaller. So that's okay. I can say that. That's my claim. It's answering the question. I'm taking the side. I'm taking the stance there. Now I need to provide evidence. So my first piece of evidence is going to be when the flies touched the meat, there was larvae. Right? If I say that, That's not enough evidence because in that experiment, when the flies touch it, so did the air. So I can't just say that. Can I use this one? Well, the flies didn't touch it on that one, so I can't really support that. But this is a great one to do our counterclaim because in this one, the flies didn't touch it. The air did, but still we didn't see any of them. So that basically eliminates the idea that air can produce maggots, and that's not the case, right? So I'll go and then I'll go. So that's my first piece of evidence. I'm going to go and mention the second piece of evidence. When only the air contacted the meat, there was no larvae, right? So what does that mean? Well, let's kind of summarize and put those together. Therefore, there must be direct contact between the meat and flies in order to have larvae, right? So it's kind of mentioning this, but it is also touching on this. It's kind of summarizing and bringing it together. Okay, and I'll show you guys better examples of reasoning, but for now, we'll keep it somewhat simple. Okay, and that's pretty much it. That's an example of claim evidence reasoning.